According to the National Electrical Code, the maximum size bonding conductor required to connect several electrodes is 6 AWG. This requirement is crucial for ensuring effective grounding and bonding within an electrical system. Grounding and bonding serve distinct but interconnected purposes. Grounding provides a path for fault current to return to the source, facilitating the operation of overcurrent protective devices such as circuit breakers or fuses. Bonding, on the other hand, connects non-current carrying metal parts of equipment and enclosures to create a low impedance path for fault current, thereby minimizing the risk of electric shock. The role of a bonding conductor is to ensure electrical continuity and conductivity between different parts of the electrical system, allowing fault currents to flow back to the source quickly and safely. When multiple grounding electrodes are used, they need to be connected together to form a grounding electrode system. This system ensures that all electrodes work in unison to provide a stable and reliable ground reference. The bonding conductor that connects these electrodes is subject to specific sizing requirements outlined in the NEC. The primary reason for limiting the maximum size of the bonding conductor to 6 AWG is related to practical considerations and the diminishing returns of using larger conductors. While a larger conductor might theoretically offer lower impedance, the difference in performance beyond 6 AWG is often negligible in typical residential and commercial applications. Furthermore, larger conductors are more difficult to work with, requiring more effort to bend, splice, and terminate. This increases the likelihood of installation errors and can lead to compromised connections. The NEC specifies the minimum size of grounding electrode conductors based on the size of the ungrounded service entrance conductors. However, the bonding conductor that connects multiple electrodes together is subject to a different set of rules. The requirement for a maximum size of 6 AWG applies specifically to this bonding conductor, regardless of the size of the service entrance conductors. To understand the rationale behind this rule, it's essential to consider the function of the bonding conductor in this context. The purpose of connecting multiple electrodes is to reduce the overall ground resistance of the system. By connecting several electrodes in parallel, the combined resistance to ground is lower than that of a single electrode. This improves the effectiveness of the grounding system and enhances its ability to dissipate fault currents. The NEC provides detailed guidelines for the installation of grounding and bonding systems, covering various aspects such as conductor sizing, material selection, and connection methods. These guidelines are designed to ensure that electrical systems are installed safely and reliably, minimizing the risk of electrical hazards. In addition to the 6 AWG maximum size requirement for bonding conductors, the NEC also specifies minimum size requirements for grounding electrode conductors based on the size of the service entrance conductors. These minimum size requirements are intended to ensure that the grounding electrode conductor can safely carry the maximum fault current that is likely to occur. It's important to note that the 6 AWG maximum size requirement applies specifically to the bonding conductor that connects multiple electrodes together. The grounding electrode conductor, which connects the grounding electrode to the service equipment, may need to be larger than 6 AWG depending on the size of the service entrance conductors. When installing a grounding and bonding system, it's crucial to follow the NEC guidelines carefully to ensure that all components are properly sized and installed. Failure to comply with these guidelines can result in an ineffective grounding system, which can increase the risk of electrical shock and equipment damage. In summary, the 6 AWG maximum size requirement for bonding conductors connecting multiple electrodes is a practical limitation designed to balance performance, cost, and ease of installation. While larger conductors might offer slightly lower impedance, the difference is often negligible in typical applications. By adhering to the NEC guidelines, electricians can ensure that grounding and bonding systems are installed safely and effectively, protecting people and property from electrical hazards. The specific NEC articles that address grounding and bonding include Article 250. It is essential to consult the latest edition of the NEC and applicable local codes to ensure compliance with all requirements. Article 250.66 covers the sizing of grounding electrode conductors, while Article 250.64F specifically addresses the bonding of multiple electrodes. Understanding these articles is crucial for properly designing and installing a grounding and bonding system. When multiple grounding electrodes are present, they must be bonded together to form a unified grounding electrode system. This is typically achieved by connecting the electrodes with a bonding jumper, which must be sized in accordance with NEC requirements. The bonding jumper ensures that all electrodes are at the same potential, preventing voltage differences that could create a shock hazard. The size of the bonding jumper is determined by the size of the grounding electrode conductor, but it does not need to be larger than 6 AWG. This is because the primary purpose of the bonding jumper is to equalize the potential between the electrodes, not to carry the full fault current. The grounding electrode conductor, on the other hand, must be sized to carry the maximum fault current that could occur on the system. The NEC provides tables and guidelines for determining the appropriate size of the grounding electrode conductor based on the size of the service entrance conductors. In addition to the bonding jumper, all metal parts of the electrical system must also be bonded together to create a continuous electrical path to ground. This includes metal conduits, enclosures, and equipment grounding conductors. Bonding these metal parts together helps to minimize the risk of electric shock by providing a low impedance path for fault current to flow back to the source. The bonding connections must be made using approved methods and materials such as bonding bushings, bonding jumpers, and grounding screws. These connections must be mechanically secure and electrically conductive to ensure that they can effectively carry fault current. When installing a grounding and bonding system, it's important to pay attention to the details and follow the NEC guidelines carefully. This includes properly sizing the conductors, making secure connections, and protecting the conductors from damage. A properly installed grounding and bonding system is essential for ensuring the safety and reliability of an electrical system. In summary, the 6 AWG maximum size requirement for bonding conductors connecting multiple electrodes is a specific provision in the NEC that is designed to balance performance, cost, and ease of installation. While larger conductors might offer slightly lower impedance, the difference is often negligible in typical applications. By adhering to the NEC guidelines, electricians can ensure that grounding and bonding systems are installed safely and effectively, protecting people and property from electrical hazards. It is also important to understand the difference between grounding electrode conductors and bonding jumpers, as they have different functions and sizing requirements. Grounding electrode conductors connect the grounding electrode to the service equipment, while bonding jumpers connect multiple electrodes together. Both types of conductors are essential for creating a complete and effective grounding system. Article 250.53c of the NEC discusses the requirements for the common grounding electrode. This section mandates that if multiple electrodes are present at a building or structure, they must be bonded together to form a single grounding electrode system. This ensures that all grounding electrodes work together to provide a low impedance path to ground. The bonding conductor used to connect the electrodes must be sized in accordance with Article 250.64F, which specifies the 6 AWG maximum size. The reason for this limitation is that the primary purpose of the bonding conductor is to equalize the potential between the electrodes, not to carry the full fault current. The grounding electrode conductor, which connects the grounding electrode system to the service equipment, is responsible for carrying the fault current. This conductor must be sized in accordance with Article 250.66, which provides tables and guidelines for determining the appropriate size based on the size of the service entrance conductors. It is important to note that the 6 AWG maximum size requirement only applies to the bonding conductor that connects multiple electrodes together. The grounding electrode conductor may need to be larger than 6 AWG depending on the size of the service entrance conductors. When installing a grounding electrode system, it is also important to consider the type of electrodes being used. The NEC recognizes several different types of grounding electrodes, including metal underground water pipes, metal frames of buildings, concrete encased electrodes, and ground rods. Each type of electrode has its own specific installation requirements, which must be followed to ensure that the electrode is effective. For example, ground rods must be driven at least 8 feet into the ground and must be spaced at least 6 feet apart. Concrete encased electrodes must be encased in at least 2 inches of concrete and must be located within the bottom 20 feet of a concrete foundation or footing. The NEC also provides guidelines for the use of supplemental grounding electrodes. A supplemental grounding electrode is an additional electrode that is installed to improve the effectiveness of the grounding system. Supplemental electrodes are often used in areas with high soil resistivity or in situations where the existing grounding electrode is not adequate. When installing a supplemental grounding electrode, it is important to bond it to the existing grounding electrode system. This can be done by connecting the supplemental electrode to the grounding electrode conductor or to the bonding conductor that connects multiple electrodes together. The bonding conductor must be sized in accordance with Article 250.64F, which specifies the 6 AWG maximum size. In summary, the 6 AWG maximum size requirement for bonding conductors connecting multiple electrodes is a specific provision in the NEC that is designed to balance performance, cost, and ease of installation. By adhering to the NEC guidelines, electricians can ensure that grounding electrode systems are installed safely and effectively, protecting people and property from electrical hazards. It is important to understand the difference between grounding electrode conductors and bonding jumpers, as they have different functions and sizing requirements. It is also important to consider the type of electrodes being used and to follow the specific installation requirements for each type.